We'll go over here. All right, welcome to the wonderful world of electron configuration. Mr. Holt's here to just kind of review some stuff and go over a couple examples. I feel weird, I'm half and half here. So yesterday we started to talk about orbitals and energy levels. I just wanted to review what the different letters meant and the actual energy levels. So the numbers are telling you what energy level. That part Niels Bohr had correct going through there. We've now moved past into what we call orbitals, where there are four different orbitals of various sizes. You have the s orbitals, the p orbitals, d, and F. So as we go through, we're going to teach electron configuration with a really cheesy example. I hope that helps as we go through. So just to do a quick review in your head, maybe we'll ask some people, what is an orbital? What does an orbital mean? Miss Bethke. Miss Bethke.
Yeah. What?
Oh, it's just like teaching you guys. What is an orbital?
An orbital? That sounds like orbit? Is that gum?
No, it is not.
Oh, orbit. That's what the planets do when they go around the sun.
Correct, but not an orbital.
Orbital. Oh, it's a mathematically defined three-dimensional space where 90% of the time there's a high probability of finding an electron.
Nice, good job. Isn't it fun when you're awake and Chem is trying? All right, so there's a lot of rules. There's a lot of things. We are not going to test you on what the rule is, who came up with the rule. When I teach this in person, I usually compare it to tying shoes. I don't care who invented tying shoes. I just know how to do it. Electron configuration and orbital diagrams kind of go along the same way. So when I teach this, this is my orbital apartment building. I'm going to teach you the rules without you knowing. So a couple things about this apartment building to help you learn the rules. First, there is no elevator. So if you're going to live on the 7th floor, you got to walk a lot of stairs. Second rule, every apartment needs to have two people in it. And how I define that and show that, there's actually two views. There's the north side and the south side. The north side's beautiful. There's a pond with swans and a waterfall, gorgeous. So if you're the first one in the apartment, we will put that with just a little up arrow. South side, alley cats going, not so great, but we're going to show that down arrow. So you can't have two beds by one window. We go up arrow, down arrow. Every building or every apartment needs to have two people in it. So basically, I'm just going to do an example of everyone's favorite element, titanium. And titanium has 22 family members, or 22 arrows we're going to need to put in here. So we sing crappy Drake songs. We need to put 22 arrows. We started from the bottom. Now we're here. So we would go up, down, and one S is filled. We filled the first energy level. We have 20 more electrons to go. So we move up the stairs, and we would go up, down again. Now we have 4 electrons. We got 18 more to go. Now we go down the hall, 2nd floor, 2P. This is our 3-bedroom. The last rule we talk about, I often call it the empty bus seat rule, is if I walk into a bus, I don't sit right next to where someone's already sitting. I find the two, well, I do, but I'm weird and awkward. Most people go and find 2 empty seats and you sit there. If you had a 3-bedroom apartment, do you want a roommate if there's 2 extra rooms available? Probably not. So the rule of these are, we would go up. Someone filled this room. We don't want a roommate. Up, up. Now that there's 1 in each, now we fill up this. Down, down, down. It's like the push-up test in Phi Ed. Up, down, up. We're at 10. 12 more to go. Second energy level or floor is filled, so we go up the stairs. Up, down. There's 3S. We're at 12. Again, we have a multi-bedroom. We go up, up, up. 15. Down, down, down. 18.
Mr. Holt, Mr. Holt.
Oh, question.
I want to know. Could I have gone down, and then up?
Oh, whoa. We tend to go up before down because it's actually due to the electron spins.
Oh, that's what the arrows are?
That's what the arrows are.
No wonder I feel so dizzy. It spins.
But note, we will keep them consistent. You can't go up, up, or anything like that. Here's where you guys get frustrated and say, why are you spending so much time doing this? Let's just go to 3D. Some hallways are so long, it takes less energy to go up the stairs. Confusing, right? But we would go up, down. There's 20. We need 2 more. Well, now we walk down the hall and go up, up. So this being on a video is going to be awesome. It's going to be so cool for you because now you could go back and look at this. If I click to the next slide, all of you getting angry, it doesn't make sense. If you follow this order, this is also on a PDF in your notes, you should see it followed this exact order here. Now note the energy gap starts very large, and as you move away from the nucleus, it starts to get closer together. We'll talk more about that as we go through this week, but this should follow. We're right here for those that like horizontal things. 1s, after 1s comes 2s, then it fills to 2p. You can see it follows there. I like to think of this as rising water. It cannot fill the next boxes until this is all filled up. So after 2p comes 3s, then 3p. And here's the part where everyone gets frustrated. It's not just all the 3s and then all the 4s. After 3p comes 4s and then 3d. So whether you like this one, I know some people write that down, whether you like this and the PDF is kind of printed for you. So just general, remember number means energy level. That's how far you are, you're getting away from the nucleus. And when it comes to the drawings, everyone stresses about drawings. These orbitals and sublevels are basically telling you how many orbitals or boxes are in each. So what we're going to make you do is long way first. No one really likes this because drawing a bunch of boxes and arrows isn't fun. Then we'll get to the shortcut. But I just wanted to show kind of how this works, a couple examples so you're ready for the homework today. So when it comes to silicon, you may have to find it on your periodic table. Miss Becky, do you know what number silicon is?
That's silly. Of course, it's number 14.
Nice. Number 14, that means we need 14 electrons. So what the orbital diagram is, if you go back to this, it's pretty easy. You're following this. We would start with our first is 1s. I draw a box and I would go up, down arrow. There's 2. 1s is now filled. We move on to the next one, 2s. S again means 1 box, and we would go up, down. There's 2s. Going back to this, what comes after 2s is 2p, 2p, and anytime I draw p, p needs to have 3 boxes. We would go up, up, up. There's 7. Down, down, down. Now we're up to 10. What comes after 2p is 3s. Up, down. Of course, your boxes will all be the same size and consistent. Finally, we get 3p. There are 3 suborbitals there, and then we're at 2, 4, 6, 8, 10, 12, 13, 14. You just did your first orbital diagram. Isn't that exciting? These can get very long, not so fun. So what we've come up with, maybe not we, but we use it, is an electron configuration, which is basically a shortcut to all of this. So instead of drawing the boxes and arrows, we would say 1s, and how many electrons are in that s? 2. 2s, how many are in there? 2. 2p, how many arrows total are in there? Would be 6. 3s with 2, and then finally 3p, and there's only 2 in there. If you add the little numbers up, they should add up to however many electrons you total. So for those that need another shorter one, I got you. Nitrogen. Nitrogen is number?
Good night.
Oh.
Nitrogen is number. Oh, Mr. Holtz, you knew.
I knew. Yes. 7. So I'm going to go through this one faster. We have 1s. Up, down. 2 down, 5 more to go. 2s. Up, down. 4 down, 3 more to go. 2p. Again, empty bus seat rule. You would have to go up, up, up. There's our 7 electrons. Electron configuration, you'll notice, is much faster, much easier. 1s, we don't say 1s squared. That's silly. That's math. This is chemistry. 1s2, 2s, 2, 2p, 3. And again, adding those little numbers up. Nice way to check, did I do this right? 7 electrons. Boom! Nailed it. For those stressing out right now, take a deep breath. Perhaps go back, watch the video again. Don't worry, we're going to have more electron configuration fun in your future. Have a great day, everyone.